Okay, here's a thought experiment for you. If I surgically removed your stomach right now, just took it out completely, put it on the table here, do you think you would still feel hungry?
That is a pretty visceral and honestly a terrifying image. But looking at the physiology, yeah, yes, you absolutely would.
See, that sounds completely wrong. I think for most of us, when we're starving, we grab our stomach, we hear it growl, you feel that, physical emptiness right there.
Mm-hmm.
But the research we're digging into today says that hunger, that driving, gnawing feeling, it doesn't actually live there.
It really doesn't. It's a phantom signal in that case.
Yeah.
The stomach's just the fuel tank, the dashboard telling you the tank is empty. That's located somewhere else entirely.
In a command center.
Upstairs, yeah. It's a signal from the brain.
And that very distinction, between the body's machinery and the brain's signals, that's exactly why we're here. So, hello everyone.
And welcome to the deep dive.
Today, we're not just talking about why you eat a sandwich or drag yourself to the gym at 6 in the morning. We are looking under the hood of human behavior. We are talking about the architecture of motivation.
And for so many people, motivation is this really fuzzy, almost mystical idea. It gets treated like a synonym for grit or, character. You either have that fire or you don't.
Right, the whole just do it mentality. But the reality that psychology paints is it's much more mechanical, it's almost robotic. Less about spirit and more about switches and chemical thresholds and these biological feedback loops.
It's a really complex interplay. We're going to break down 4 specific frameworks that try to explain why we do anything at all. Instinct, drive reduction, arousal theory, and the big one, the hierarchy of needs.
So let's start at the very basement level, the firmware we all come pre-installed with, instinct.
This is the evolutionary perspective. The classic example is the salmon. A salmon swims upstream to spawn, it fights currents, leaps up waterfalls, risks getting eaten by a bear. It doesn't take a class on it.
Right, it doesn't weigh the pros and cons.
No spreadsheet, nothing. It just acts. It's hardwired software, an inborn automated pattern of behavior.
And early on, psychologists tried to use this instinct theory for everything humans did, right? Like, why do we fight? Aggressive instinct.
Exactly. Why do we gossip? Social instinct.
But that feels like such a cop-out. You're just naming the behavior, not explaining it. It's circular logic. I do this because I have an instinct to do it.
And that's the fatal flaw. We are just a little bit more complicated than the salmon. Instincts can explain, reflex like flinching when a ball flies at your face.
Sure.
But they don't explain why you chose to listen to this deep dive instead of sleeping in, or why you're saving money for vacation.
Which brings us to the second framework, which gets a bit closer. Drive reduction theory.
Okay, so this one seems to be all about the idea of homeostasis.
It is. Think of homeostasis as like biological neutrality. Your body constantly wants to be in a state of balance. Stable temperature, stable fluids, stable energy.
Like a thermostat your house set to 70 degrees. That's a great analogy. So when you move away from that balance, say your water levels drop, you have a biological need. And that physiological need creates this psychological tension, this uncomfortable state we call a drive.
Thirst.
So the motivation, the act of drinking water, isn't about enjoying the water. It's about killing the tension.
It's about reducing that drive to get back to zero, back to homeostasis.
It's a push from the inside. And we have these primary drives, hunger, thirst, survival stuff. But we also develop secondary drives like wanting money or social approval because we learned they help satisfy the primary ones.
But this is where the theory gets a little shaky for me. Because drive reduction implies that our ultimate goal is just to relax, to have zero tension. If that were true, the happiest human would be someone in a dark, quiet room, totally fed, doing absolutely nothing.
Which is clearly not the case.
Right. I mean, think about boredom. If homeostasis was the only goal, we'd love being bored. But we hate it. We watch horror movies on purpose. We ride roller coasters. We seek out stress.
That contradiction is the perfect way into our third framework, arousal theory. You're right, we don't want zero stimulation. We want the optimum level of arousal.
The Goldilocks zone of stress.
In a way, yeah. And there's a governing principle here that is so critical to understand, especially if you're, say, a student trying to perform well. It's called the Yerkes-Dodson law.
I love this concept. Okay, so let's unpack Yerkes-Dodson. How would this apply to something really practical, like studying for a final exam?
Okay, picture a graph. Vertically, you have your performance, how well you do. Horizontally, you have arousal, so alertness, stress, excitement. The law basically says that performance goes up with arousal, but only up to a point.
So if I'm trying to study and my arousal is too low, I'm half asleep in a hammock, my performance is awful. Too relaxed to focus.
Exactly. The brain isn't engaged, but if your arousal shoots way too high, you're panicking, you've had way too much coffee, you're terrified of failing, your performance just crashes again.
You get tunnel vision. You freeze.
So for difficult tasks, you obviously want a moderate level of arousal. You want to be keyed up, but not totally freaked out.
That explains so much. It's why I can, like, run when I'm angry, but I absolutely cannot do math when I'm angry.
It's a delicate balance. So we've got instincts, we've got this drive to fix our biological needs, and we have this psychological need for stimulation.
Yeah.
But let's circle all the way back to that terrifying image from the start.
The stomach. Right, so if hunger is a drive and it's not in my stomach, where's the switch?
It's deep in the brain, specifically in a structure called the hypothalamus.
The hypothalamus. We hear about this little guy in almost every single behavioral context.
It's the control center for the body's maintenance. And for hunger, the research points to two very specific spots that act almost like a light switch, an on and an off.
Okay, walk us through the on switch.
That's the lateral hypothalamus. When this little cluster of neurons gets stimulated, you feel hungry. It doesn't matter if you just ate a 5-course meal. If I zapped your lateral hypothalamus, you would immediately start eating again.
And the research mentions some pretty grim experiments if you damage it, right?
Yes, if you lesion it, basically destroy it. In a lab rat, the animal loses all interest in eating. It would starve to death, literally standing in a pile of food because the start eating signal just never fires.
That is wild. It's not that they can't physically eat, they just have no motivation to. Okay, so what's the off switch?
The ventromedial hypothalamus does the exact opposite. Stimulate it, you feel full, destroy it. And the subject just becomes a bottomless pit. It will eat and eat until it's severely obese because the stop signal, the satiety signal, is broken.
So our weight isn't just about willpower. It's a chemical balancing act run by this tiny part of the brain.
It's a whole feedback loop. Your brain is constantly monitoring your blood chemistry. When your glucose, your blood sugar drops, hunger goes up, insulin converts that glucose to fat, and your hypothalamus is just reading these levels like a stock ticker, deciding which switch to flip.
Which brings up the set point theory, the idea that the hypothalamus is like that thermostat we mentioned, but for your body weight.
Right. The theory suggests your body has this weight thermostat. It wants to maintain a stable weight range. And this is why dieting is so physically miserable.
Because you are fighting your own hardware.
You are. If you drop below your set point, your lateral hypothalamus goes nuts. But it doesn't just make you hungry. It actually slows your metabolism down to conserve energy.
Your body thinks you're in a famine.
And it fights to get you back to that set weight.
Okay, but biology can't be the only thing going on here. We have to talk about culture. Because if hunger was purely biological, just about glucose, we'd all be happy eating some bland nutrient paste every day.
Very true. Psychological and cultural factors are massive. We eat when we're not hungry because the clock says noon. We eat because we're at a party and everyone else is eating.
The source material had some pretty vivid examples of this. Foods that are delicacies in some places but might make you gag in others.
I think you're referring to the mice wine.
The mice wine, yes. Baby mice fermented in rice wine or fried frog legs.
Which are delicious for the record.
I will have to take your word on that one. But the point is, biology tells you eat energy, but culture tells you eat this specific thing or definitely don't eat that thing. It overrides the pure instinct.
It creates an external incentive. We're motivated by the idea of the food, the social part of it, not just the calories.
Okay, now I want to pivot here because this whole interplay between biology and behavior gets really messy and kind of judgmental when we talk about weight.
How so?
Well, with the rise in obesity, the common narrative is pretty harsh. It's usually framed as a failure of character. You know, eat less, move more. If someone's obese, we just assume it's because they make bad choices or lack discipline.
See, I have to push back on that interpretation a little bit. The research doesn't really support that kind of simplicity.
Why not? I mean, at the end of the day, you control what you put in your mouth, don't you?
That's the willpower myth all over again. The psychology of obesity is pretty clear. While habits matter, some people are biologically predisposed to obesity in ways they just can't think their way out of.
Predisposed how?
Well, go back to the set point theory. If someone has a genetically higher set point, their body is actively fighting against weight loss every single second. Their hunger switch might fire off sooner than yours. Their full switch, that ventromedial hypothalamus, might not fire as strongly.
So they might not even feel fully satisfied after a meal.
Exactly. And then you have the thrifty gene hypothesis. Evolutionarily, The people who stored fat easily were the ones who survived famines. For most of human history, they were the genetic winners. In a world of unlimited fast food, that survival tool becomes a health liability.
So you're saying it's not just a lack of discipline.
I'm saying the deck is stacked differently for different people. To reduce obesity down to just choices completely ignores the biological engine driving the car.
That's a fair correction, and when that engine and our psychology get totally out of sync, that's when we see eating disorders.
Which is really the dark side of motivation, the distortion of that fundamental drive.
We see this so clearly with anorexia nervosa. It's defined by starving yourself to below 85% of your normal body weight.
And the key part is the cognitive distortion. A person with anorexia can look in the mirror and genuinely truly see themselves as overweight, no matter what reality is. It's tragic because it's complete biological override. They are fighting millions of years of evolution screaming at them to eat.
And then there's bulimia nervosa, the cycle of binging and purging.
Right. And what's interesting is that the data shows the vast majority of these cases are women, which points right back to those cultural pressures we mentioned. The ideal body image that society sells is powerful enough to hijack the brain's most basic survival signals.
Okay, speaking of biological overrides and deep-seated drives, we have to talk about the other big evolutionary motivator.
Sex.
Sex. The research is pretty blunt about this. Without sex, none of us would be here. It is the ultimate survival mechanism for the species.
But it's unique. Hunger is a need. If you don't eat, you die. Sex is a desire. If you don't have sex, you might be unhappy, but you won't physically perish.
And we only really have data on this thanks to a few pioneers. Alfred Kinsey back in the 50s and Masters and Johnson in the 60s.
Kinsey was just revolutionary because he just asked people. He did confidential interviews with 18,000 people. He took this taboo, whispered subject and dragged it into the light of day.
And he developed the famous Kinsey scale, right?
Yes. The idea that sexuality isn't some binary switch gay or straight, but a spectrum.
Right.
0 is exclusively heterosexual, 6 is exclusively homosexual, and there are all these shades in between.
But the really contentious part of this topic historically has never been the what or the how, it's been the why. Why are we attracted to who we're attracted to?
This is the big question. Sexual orientation. And I think for a long, long time, the cultural belief and even the psychological belief was that it was all about nurture. You know, a distant father or an overbearing mother, something that happened in childhood.
Right, the idea that you somehow learned to be gay or straight depending on how you were raised, but the science drops a pretty heavy anchor here.
It really does. Current research finds no evidence, 0, that sexuality is socially determined. Kids raised by gay parents are no more likely to be gay than kids raised by straight parents. It's not about parenting. It's not a result of trauma.
So if it's not social and it's not a choice, we're back to biology.
We are back to biology. And the evidence is just fascinating. There was a huge breakthrough by a researcher named Simon LeVay. He looked at the brain structure itself.
And the hypothalamus makes a comeback.
It does. LeVay found a specific cluster of cells in the hypothalamus. It's called INAH3. And what he found was that this cluster is significantly larger in heterosexual men than it is in women or in homosexual men.
So there's an actual physical hardware difference in the brain.
It appears so, and it likely happens before you're even born. The research points to the prenatal environment, specifically hormone levels in the womb during these really critical developmental periods.
This is the part that just blew my mind, the real weird science moment in the research.
The fruit flies.
The fruit flies and the sheep.
Yes. Scientists have actually been able to manipulate these prenatal conditions and basically create homosexual male fruit flies. And in nature, we see what you could call lesbian sheep.
That's the detail that sticks with me. Sheep don't have these complex societal structures. They don't have overbearing mothers in the Freudian sense. They just are.
It completely reframes the whole debate. If it's determined by a cell cluster in the hypothalamus and prenatal hormones, then looking at orientation as a lifestyle choice is just, it's scientifically illiterate. It's biological architecture.
Okay, let's pull ourselves out of the biology lab for this last part. We've talked about food, we've talked about sex, the really primal stuff. But most of us listening aren't hunting for berries right now. We're motivated by something else, like getting a degree or a promotion or mastering a skill.
Achievement motivation, the psychology of work.
And there's a classic divide here that I think everyone understands intuitively, but maybe hasn't put a name to. Intrinsic versus extrinsic.
It's simple, but it's so powerful. Intrinsic motivation is doing something because you just love it. The reward is the activity. You play guitar because it feels good to make music.
And extrinsic is doing it for the cookie, or the grade, or the paycheck.
Exactly. And here's the trap. We assume that if you add a reward, motivation just goes up. But the research shows that extrinsic motivators can actually kill your intrinsic drive.
The over-justification effect.
Yes. If you love to read, and I start paying you $5 for every book you finish, your brain starts to shift. It starts to see reading as work. And if I stop paying you, you might stop reading, even though you used to love it for free.
That is a huge warning for parents and teachers. And it leads right into how we manage people. To Douglas McGregor's management theory. Theory X and Theory Y.
To me, this just sounded like the bad boss versus the good boss.
That's a simple way to put it, but yeah, it's pretty accurate. So a manager operating on Theory X believes that employees are just naturally lazy, they hate work, and they avoid responsibility.
So their entire management style is about control. If I don't watch over your shoulder and threaten to fire you, you won't do any work.
Right. They're targeting the very bottom of Maslow's hierarchy. Your safety, your physiological needs, do this or you starve. It relies purely on extrinsic stuff, fear and money.
And Theory Y.
Theory Y is the total opposite. It's the belief that people actually want to do a good job, that work is as natural as play. So a Theory Y manager believes that if you give people autonomy and respect, they will be self-directed. They'll be motivated.
They're appealing to the very top of the hierarchy, self-actualization.
Exactly. And the research generally shows that Theory Y leads to happier, more productive, more innovative teams because we're not just rats in a maze looking for cheese. We want meaning. We want to feel competent.
So what does this all mean? We've gone from the lateral hypothalamus all the way to the corporate boardroom.
I think the big takeaway is that we aren't the purely logical commanders of our own ship that we like to think we are. We're piloted by this mix of ancient biological switches, like that glucose monitor in your brain, and these really complex, high-level psychological needs.
We're part salmon, swimming upstream because our biology demands it, and part artist, trying to reach self-actualization.
And understanding that architecture just helps you navigate your own life. If you know you're hangry, you can recognize that's your hypothalamus talking, not your personality. If you're bored, you know you need to adjust your arousal level. If you hate your job, well, maybe it's because your boss is stuck in Theory X and is killing your intrinsic drive.
That raises a question I want to leave everyone with today. We talked about managers, but
Okay.
you're also your own manager.
Oh, that's good.
How do you treat yourself? Are you a Theory X boss to yourself? Do you beat yourself up, threaten yourself, rely on fear and guilt just to get off the couch?
Or are you operating on Theory Y? Do you trust your own internal drive? Do you give yourself the autonomy to explore what you're actually interested in?
Trusting that if you create the right environment for yourself, the motivation will follow. That is a powerful thought to chew on. Thanks for diving in with us.
See you next time.